Okay, this is pretty much how radical functions move. It's very similar to how absolute value functions move and how quadratic equations move. So you'll see a lot of similarities here. In the first one, y equals negative absolute value x. Anytime you see that equation, you have to assume it's going to be a reflection on the x-axis. If we have y equals a square root of x, that indicates a stretch or a shrink. And that value of a determines that if it's like a 3 or a 4, it's probably going to grow a lot quicker. If it's like a 1/2, it's going to grow a lot slower. Y equals the square root of x minus h. That moves the radical graph to the left or right. Square root of x and then plus k outside of it. That moves your graph on the y-axis up and down. And then y equals the square root of x minus h. Plus k is a combined movement, so it'll move both left and right and up and down. Now this, I know I have it written all under square roots. It applies to cubic functions, quartic functions, you name it, it applies to it, as long as it sits in the radical family. Here's your parent function of a y equals the square root of x, so of a square root function. Notice the origin, or it starts here at 0, 0. Here's an example of the y equals negative square root of x. Notice the reflection of the parent function on the x-axis. Here's an example of the y equals a square root of x. Notice I have different a values and it just changed the growth rate of the radical function. Here's an example of the y equals the square root of x minus h. In this case, I had x minus 5, so the red one, so I went right 5 units, x minus 1, orange, x plus 2, left 2, x plus 3, left 3. Here's an example of the y equals the square root of x and then plus k on the outside. Obviously on the outside it was minus 5 for the red one, minus 1 for the black, plus 2 for the purple, and plus 4 for the red. Just moves it up and down on the y-axis. Here's an example of the combined, the y equals the square root of x minus h plus k. Notice this red one down here, I must have had plus 1 on the inside, minus 5 on the out, and that's just how it moves it, and the a value is. Wanted to show you examples of how it applies to cubic functions as well. This is the parent function of a cubic, so y equals the cube root of x. Here is the y equals negative cube root of x. Notice it just reflects it on the x-axis. It turns it and as it goes that way. Here's an example of the y equals a, so a number, cube root of x. Notice I think the orange was like a 1/2, the blue was like a 2 or a 3. And here's an example of the y equals the cube root of x minus h. And for the blue, I had y equals x minus 3. Notice how it moves to the right 3. And for the green, it was plus 2. Notice how it moved to the left 2, but it still makes the same movement. This is the y equals the cube root of x plus k. Notice how it moves up and down on the y-axis, or the point of inflection. You know, that's that point that looks like it goes vertical. It's down. Here would be an example of y is the cube root of x minus h plus k, so a combined movement. Notice how your point of inflection for the green here looks like it moves left 2, down 5, so it must have been a function like the cube root of x plus 2 and then minus 5 on the outside. The same scenario for the blue. Okay, for graphing square root functions, we're going to look at the function on the left here. The y equals negative 2 square root of x plus 1 minus 3. So using the families of functions and basically what their graph does, we can kind of visualize this graph. I see it's negative, so I know it's going to open down, reflected on the x-axis. Since the plus 1's on the inside, I know that my starting point is going to move to the left 1, and then the negative 3 on the outside indicates it's going to move down 3. So I already kind of have that mental image, and then that 2 means it's going to grow a little bit quicker than it would if it's a 1. So I can already kind of visualize and graph left 1, down 3, put my point, and then draw a little bit quicker growth. So let's look at the graph of this and make sure it matches what I just described. So see, we have that function left 1, down 3. There's my starting point. And notice it does grow a little bit quicker than it would be if it was just a negative 1 square root of x plus 1 minus 3. So our description matches, so that, once again, that worked. Okay, here we're going to look at the square root function on the right. We have y equals 1/4 square root of x minus 2, and then minus 4 on the outside of that. This, again, mental image, the 1/4 means it's going to just grow a lot slower than it would be if it was just a 1 out there. The x minus 2 on the inside, that minus 2 is going to translate our starting point to the right 2 units, and then the minus 4 out on the outside is going to translate it down 4 units. So I can already imagine that the starting point's right 2, down 4, and it's going to grow really slow from that point. So why don't we check out the graph and see if it matches our verbal description here. And there you have it, right 2, down 4, and as you can see, it grows very slowly there, so it matches our verbal description. So once again, using those rules applies to radical functions as well. Okay, here we are graphing cubic functions. It's the same way as square root, so we can use the same verbal description. So the x plus 3, that means it's going to move to the left 3, our point of inflection, okay, will move to the left 3 units, down 1 unit, and then that 2 means it's going to grow a little bit faster rate than the other one. So let's look at that function on the left here and see what our graph looks like. And there we have it. As you can see, our point of inflection, left 3, down 1, and then it makes that turning point, that point of inflection there. So it does that and goes about its way and looks just like the parent function, except it's translated left 3, down 1. And it grows a little bit faster. Okay, we're going to look at the one on the right here now, y equals 3 minus the cube root of x plus 1. So because it's minus the cube root, that means it's a negative function, so we can anticipate it's going to be reflected. So it's going to start up and end down. The plus 1 means it's going to shift to the left 1 unit, that point of inflection is, and then that 3 means it's going to shift up 3 units. So I can expect this graph to go left 1, up 3, and grow at the same rate. It's just going to be reflected down. And like we described, that point of inflection here went left 1, up 3, and it starts from the left and finishes to the right, but finishes down towards the right. Remember when we had absolute value functions and the x wasn't 1, we factored a value out to make it 1? Well, we do the same thing here. So in this case, we'd factor the 4 out, and we would get y equals the square root of 4, x minus 3. Because we're talking square roots here, we can actually take the square root of 4, which is 2, and we have y equals 2 square root of x minus 3. And now that we have that rewritten, it's a lot easier to graph, because I know that it's going to grow a little bit faster at a rate of 2 instead of at a rate of 1, and I can move my starting point to the right 3 units. So why don't we check out that graph and make sure that's accurate. And there we have it, right 3, and look at the growth rate, a little bit faster than if the a out there was just 1. Okay, we're going to look at the one on the right here. So y equals the cube root of 8x minus 24 plus 3. Again, that 8, we don't like anything other than 1 as our leading coefficient. So let's see if we can factor the 8 out. When we do, we have 8 and then x minus 3. The cube root of 8 we can actually take. So the cube root of 8 we remove, and we get 2 cube root of x minus 3 and then plus 3. So knowing that, again, it's going to grow a little bit faster at a rate of 2. I'm going to shift to the right 3 units and up 3 units. So that point of inflection will be right 3, up 3, and then it'll grow at a little bit faster rate than if that a were a 1. And here's the graph to show that that point of inflection went right 3 units, up 3 units, and grows at a little bit faster rate.